Hello, it's Miss Shi, and welcome to your video notes for Unit 5, and this is the third video notes. Today's video is very exciting. It is on trigonometric ratios. And if you've never been introduced to the sine, cosine, and tangent functions, I am truly honored to be able to be one of the first people to tell you about these ratios, because trig functions pretty much unleash a lot of natural phenomenon in the world. There's a lot of things that can be explained from the light waves. Everything you see is in waves. Everything from the music in your headphones, everything involving waves also involves trigonometry. But we won't be able to cover that in depth this year. We are only going to be able to scratch the surface, but I'm still honored to be able to do that for you. So the vocabulary we're going to use today is opposite and adjacent and hypotenuse, which you've heard of, right triangle, theta, and this is the symbol for theta. I might say Pythagorean triple somewhere. Sine ratio, here are the big ones: sine ratio, cosine ratio, and tangent ratio. So in this video, you have to listen to how I say these ratios and these functions, because if you say them incorrectly, you're going to sound a little silly, and I don't want that to happen. So listen to how I say these words throughout this time. But by the end of the video, you are going to be able to identify and label opposite and adjacent sides of a right triangle and the hypotenuse. And then you're also going to identify the sine, cosine, and tangent ratios of a right triangle given theta. So if you don't know what that means, stay tuned. We're going to start with, this is such a big topic, and how I'm going to start this is through some vocabulary. So I'm going to draw in a right triangle as best as I can. It's a little weird with this pen, but a right triangle. And we're going to name the sides here. Normally I say like leg, hypotenuse. We do know this one. Opposite, see I'm starting already, opposite of the 90-degree angle is the hypotenuse. Hypotenuse. And it is the longest side of this right triangle. Then we have two other sides, and we need to give them names. However, I don't really know how to determine what their name. I'm just looking for a black color. Which one? Why are these all? Oh, I know. Here, let's read colors. Sorry. Okay, so there's no way that we can really identify the sides of a triangle unless we ground ourselves in a point or an angle that tells us which side. So I'm about to show you this symbol here called theta. So I'm going to zoom in on this. So this is called theta. And it is a Greek letter. And instead of using x as a variable, we're going to use theta to represent the angle here. In right triangles, I've only talked about this nice 90-degree angle, but I forget to tell you that there's two other angles that we're going to pay attention to. So the name theta is just a placeholder, just a variable name. It doesn't represent a degree necessarily, like a particular degree, just any degree that is this angle, the angle right there. Okay, so theta. To draw theta, it's kind of like an elongated O or a zero, and it has a belt, all right? Some people are fancy and they do this. Oh yeah, that's pretty fancy. But go ahead and you can just, practice drawing theta. It's a Greek letter, theta. This is how it shows up on the computer. Okay, theta. So across from theta, I mean opposite of theta. If you were on the opposite sides of the room of someone, you would be farthest away from them. So opposite theta is going to be this opposite side. Opposite. So the name of this leg is opposite because it's opposite theta. Remember, all these words are related to theta. And then you also have the adjacent side, which is next to theta. It's also the last side of the triangle. It's not the opposite one. It's not the hypotenuse. It's the adjacent. Okay? So the colors don't make sense. Don't worry about the colors. I'm just struggling. But these are the three sides of the triangle. The problem is, wait, let me write this down. So the opposite side, it means opposite. When I mean opposite opposite of theta, okay? When I mean the adjacent side, I mean adjacent to theta. And then when I'm talking about the hypotenuse, I'm talking about the hypotenuse, not of theta, the hypotenuse of the triangle. All of these ratios are going to come across right triangles, not an obtuse scaling triangle, none of that. It is a well, no, not an obtuse scaling triangle, just a right triangle. Okay, let's move on. So what's weird about this is that sometimes it doesn't look like this setup. It doesn't look like the 90-degree angle is on the right and the theta is on the left. So let me just show you. So if I were to draw another 90-degree right triangle, which is redundant. So it's not hard to draw straight lines on this thing, okay? So bear with me. So if this is 90 degrees, let's start naming and this is theta. This is theta. Say theta's in this angle here. I could have named it this angle, but I didn't. I just happened to pick this angle. So the opposite of the 90-degree side is the hypotenuse, always. Hypotenuse. That's the longest side of the right triangle. Opposite of theta, I'll write it, is the side that it is not adjacent to. So notice how this leg is not touching directly this theta. And then you have the last side, which is next to, because adjacent means next to, adjacent theta. Or how about we draw it something like, I don't know, something like this. Oh man, nice 90-degree angle, me. Yes. Please draw a better one in your notebook. It's not easy. Okay, theta's over here. Now, let's name the opposite side and the hypotenuse side and the adjacent side. So hypotenuse should be the easiest one to see. It's the longest side. Oh my gosh, this right triangle is really awful. Okay, hypotenuse is the longest side. It's across a 90-degree angle. The opposite side, is it here or is it here? Is it here? This side, opposite. It's opposite theta, and this is the adjacent side. So when I say opposite and adjacent and hypotenuse, it's related to the theta or related to the 90-degree angle, okay? So that's labeling. That's how you label these sides given theta. Let's talk about if I were to give you a right triangle. If I were to give you a right triangle, let's talk about, whoa, come back. Yeah. Oh no, I closed my, okay. Maybe it'll come back. Oh look, it's back. Sorry about that. Okay. So now I'm about to give you a right triangle and we're going to talk about the ratios. So you know what a ratio is. A ratio is the relationship between one value and another. And I should write this down. Trigonometric functions are the ratios of sides of a right triangle. Right triangle. Left triangle and then the right triangle. Wow. Okay. Trigonometric functions are the ratios of sides of the right triangle. We're not really going to get into trigonometric functions too much, but definitely the ratios we're going to hit home. All right. So if I were to give you a beautiful right triangle, say I gave you a right triangle that looked like this. Nice right triangle. Yes. Okay. Then, okay. Then I'm not very creative, so I'm going to call this 3, 4, and 5. Because you know this is a Pythagorean triple, 3, 4, and 5 right triangle. And then, so let's talk about theta here. Theta here. So 4 is the side opposite theta. 3 is adjacent to theta. 5 is the hypotenuse of the triangle. And I mentioned earlier that trigonometric functions release all kinds of natural phenomenons in the world, and it's because of these magic ratios. These ratios are so important that we even gave them names. But let's talk about what the types of ratios are first. So first of all, we have this, we have an opposite, well, okay, we'll just talk about it this way. So I'm gonna name the ratios and you're gonna have to follow along. So let's talk about the sine ratio. Sine ratio. Yes, it's pronounced sine, like the sign, like S-I-G-N, sine, but it is not spelled that way. It's spelled S-I-N-E. So the sine ratio, sine of theta, that's going to equal to the opposite, the length of the opposite side, opposite, over the hypotenuse. This ratio of opposite over the hypotenuse is so important that we gave it a name, sine, sine. And then sine has a buddy, a cosine. So we have cosine, cosine ratio. And this is abbreviated to cosine of theta. So I said earlier, you have to listen really carefully to how I say words. Adjacent over the hypotenuse. So can we just talk about how if you are not listening to this and you are just watching, you're going to say sin of theta and cos of theta? Don't do that. Don't do that. When you pronounce this, it is sine of, that's right, there's an of there, theta. Just like f of x, this is sine of theta. That's how you pronounce it, sine of theta, not sin theta. Okay, so just like this one is cosine, cosine of theta. You'll never hear me abbreviate cosine and sine. I'll just say cosine and sine. So it's just cosine of theta. Very exciting. All right. There's one more really important ratio that we're going to cover in this class, but it's not the only ratios. There's actually twice as many, but we're only going to do 3. This makes me very excited. Tangent of, tangent ratio. This tangent is the same tangent when your teacher goes off on a tangent and talks about something else. It's the same tangent and it's related, but that's, if you've ever heard tangent before, it could come from that. So tangent of theta. Sometimes I do pronounce this tan of theta, or I'll say tan theta, but this is the opposite side. This is the ratio of the opposite side over the hypotenuse. Nope, wrong. Don't know why I said that. The opposite side over the adjacent side. There's so many secrets about tangent that you don't know yet, but anyway. So this is tangent. This is pronounced tangent of theta. Very, very important that you are pronouncing these words correctly. Yeah, I know. It did quit unexpectedly. Okay. That was weird. Everybody does that. All right, so that's how you pronounce it. Sine of theta, cosine of theta, tangent of theta. Let's actually apply it to this beautiful triangle here. So there's actually a really easy way to remember this, and it's going to show up on like your ACT, SAT, stuff like that. But there's a really easy way to remember that the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. There's an easy way to remember it. Are you ready for this? Because you're never going to forget this in your life. And I'm like honored I get to be the one that teaches it to you. Man, I want to make it really bold. What's a good thing? Ready? There's an easy way to remember the ratios of trig functions. It's called so, ka, to, a. And I will say it that way. SOHCAHTOA. SOHCAHTOA. And you have to pronounce it like that. So I'll show you how this works. Sine is, sine theta is going to be the opposite over the hypotenuse. Cosine of theta is going to be the ratio of the adjacent over the hypotenuse. And tangent of theta is going to be the ratio of the opposite side over the adjacent. Okay? Let's fill this out really fast, and it's the last thing that we have to do before here. So sine of theta. So here's theta. And we wrote what was opposite, adjacent, and the hypotenuse. So the opposite side of theta is 4, the hypotenuse is 5. Boom, done. There's the ratio, 4/5. It's a fraction, friendly. We're going to use it in lots of ways, but I need you to be able to write sine of theta is equal to 4/5. Let's practice. Let's practice again. Cosine of theta. Notice I didn't say cos theta. I said cosine theta. And that's the adjacent, 4/5. Boom, done. You wrote a ratio. Brilliant. Okay, and then tangent. Sometimes I do say tan theta. Tangent of theta is the opposite side, 4/3. Boom, done. If you can take any right triangle, for example, I'm not going to record this part, but I'm going to draw one more triangle for you. And it's going to be another Pythagorean triple. All right, 5, 13, and 12. So what you need to do is find sine of theta in your notes, cosine of theta, and tangent of theta. And they're all going to be fractions. All right, so that's your last one. This is example 2. It's your last one that you have to do. I'm not going to do it with you. And you can check it in class the next day or with your teacher. Okay, summarize after you do this problem. What was the most important parts? And come to class knowing the words SOHCAHTOA. All right, I'll leave you with that. Goodbye, people.